Defining the trig functions in terms of right triangles has its limitations. For one thing, using right triangles to define the trig functions only defines the trig functions for angles between 0 and a right angle. That's 0 and 90 degrees or 0 and pi over 2 radians. But there's another way to define the trig functions, and it's in terms of circles. So let's draw ourselves a circle. And I'm going to put this in the coordinate plane. So here's the x-axis and the y-axis. And I'm going to make this as circular as I can. Okay, and we have some angle in here. So let's call this angle theta. And what you might notice whenever you put an angle with the vertex at the origin inside of a circle that's centered at the origin, it hits a point up here on the circle. Just to be concrete, let's say that this circle has radius r. So that means that this terminal side of the angle is r. This point here that we've hit on the circle has an x-coordinate, which the x-coordinate of that point is this blue distance, and it also has a y-coordinate, and that's this green distance. Now, using this diagram, you can define what all of the trig functions are. So, for example, sine of theta is the y-coordinate divided by the radius. Notice this is actually the same definition as our right triangle definition, because the side of the right triangle opposite theta is y, and the hypotenuse is r. So this is really saying the same thing as opposite side over hypotenuse, just like it was in the right triangle definition. In fact, you can see the right triangle. It's sitting right here. One side, the hypotenuse is r, and then the two legs of the right triangle are x and y. So our right triangle is actually embedded in this circle diagram. Just to define the other trig functions, at least two of the others, cosine theta is the x-coordinate over r, and tangent theta is the y-coordinate over the x-coordinate. All right, so since this diagram with this circle, you can use it to define the trig functions, and it connects the circle way of thinking about trig functions with the right triangle way of thinking about trig functions, I call this diagram the most important diagram in Pre-Calc 2. I will draw this diagram again and again and again over this quarter to the point where you'll probably be sick of it, but that just goes to show how important this diagram is. It really links so many ideas that we're going to be using this quarter. So if there is one thing you take away from this class, it should be this diagram along with the definitions of sine, cosine, and tangent. So let's use this. So here's a question. Suppose we have an unknown angle theta that's in the fourth quadrant, and the cosine of this angle is 3 over 4. Then what are sine of theta and tangent of theta? So if we try to draw a picture that reflects this situation, an angle in the fourth quadrant is going to look something like this. Okay? And so, apparently, according to the problem anyway, there's some angle down here whose cosine is 3 over 4. Well, to use this circle way of thinking about trig functions, we need a circle. So let's draw one. Now, as far as the trig functions are concerned, it doesn't matter what the radius of the circle is. So just to have a concrete radius here, well, since cosine theta is 3 over 4, cosine is x over r. So it seems like it might be nice if we chose a circle whose radius is 4. So let's make this circle radius 4. And that means that our x-coordinate is going to have to be 3. So that's the x-coordinate is this distance right here. So that's going to be 3. Well, now that we have Calm down, cats. Now that we have two sides of this right triangle, we can find the third side using the Pythagorean theorem. That third side is going to be y. So the Pythagorean theorem says x squared plus y squared equals r squared. We know x, it's 3. We don't know y yet. We know the radius, that's 4. So we get 9 plus y squared equals 16. And so y squared is 7. And so y is, well, it's plus or minus the square root of 7. One thing that this diagram will never be able to tell you is which sign here, the plus or the minus, you need to pick. So the Pythagorean theorem, no matter what you're solving for, you always have to take a square root. And so you will have to think about whether you want the plus or the minus. Just the equation itself will never tell you. But since we have a particular angle in a particular quadrant, we can use the diagram to figure out which sign we should pick, the plus or the minus. So on this diagram, this y coordinate is definitely negative because the original angle was in the fourth quadrant. So we know we have to choose the negative possibility for y. So y is the negative square root of 7. So we can put that here. And now that we know y, we knew x and r to begin with, now we can write down the value of all the other trig functions, in particular sine and cosine. So sine theta is y over r, that's negative root 7 over 4. And tangent theta is y over x, and that's negative root 7 over 3. Okay. All right. So you can see that if you can draw a diagram, a version of the most important diagram, that reflects your geometric situation, what you know about the angle and the x and the y coordinate, you can often use that to find any trig function that you want.